All right. Hello, everyone. Um, our next session is about the state of ARM firmware standards and with relation to the OSF and the collaboration between Ampere and ARM on their server platform. So my name is El-Haj-Mahmoud. I am from the ARM Architecture and Technology Group.
And hello, my name is Peter Pouliot, Senior Developer Advocate for Ampere Computing.
Thank you. All right, so we'll start by talking about ARM SystemReady. So ARM SystemReady is a standards compliance certification program that, with the goal that we have commonality in the basic building block of ARM-based systems at the silicon, at the hardware, at the firmware interfaces levels to allow for common software, standard off-the-shelf operating systems, hypervisors, and software stacks to work on different ARM SoCs without customization. The program is built on ARM architecture standards as well as industry standards, certification test suite, so actual test tools, and a certification program that takes partners through the journey of testing and publishing actual results and certifications. So for servers specific, so the program spans the entire ARM ecosystem. So it covers from the IoT and edge devices all the way to data center and enterprise servers. Focusing on servers at this summit, the main categories or classifications we have are really based on the type of firmware that you put on the machine. So we have what we call the SystemReady SR and the SystemReady LS bands or categories of certifications. The SR is based on more of the mainstream UEFI firmware specifications, whether it's open source or closed source. It does enable the wider range of operating systems that can run off the shelf on these machines. That includes Windows, NetBSD, as well as Linux, of course, the various distributions or build your own, plus VMware ESXi. With SystemReady LS, we leverage the Linux boot solution for customers that want that integration between the firmware and the operating system. And as we have seen in the presentation earlier by my colleague, by Jeff, the solution could be built Linux boot using UEFI EDK2 or Core Boot. One of these two bands is now a requirement for any ARM servers that are submitted to OCP accepted. So if a partner is building an OCP based design and they would like to submit it using an ARM SoC, and they would like to submit it to be an OCP accepted server, they need to first be certified with ARM using the SystemReady program before obtaining the OCP accepted badge. In addition, we have extensions of the program that cover other areas other than the bare metal hardware. That includes working with the cloud service providers to ensure the virtual environments, the hypervisors and the VMs that are running on them in the cloud instances are also compliant with these standards and are offering the same level of interoperability with software as they do on the physical machines. In terms of specifications, there is a number of standards. We're not going to go through all of them here today, but they cover, like I said, the silicon and the hardware. That's the BSA or base system architecture specification, as well as the SBSA, the server-specific set of hardware and silicon requirements. We do have firmware standards, which is what we are trying to focus on in this session today. So we have the base boot requirements document that outlines multiple recipes for servers, and the two common recipes that map to those system-ready bands that I just talked about are the SBBR and the LBBR recipes, with SBBR mapping to the standard system-ready SR, and the LBBR mapping to the Linux boot-based servers. We do have additional requirements for security interfaces that cover things like secure firmware update, UEFI secure boot, TPM and trusted boot, as well as secure design guidelines for servers. And along with those, there is an optional certification called the SystemReady SIE, or Security Interface Extensions, like an additional badge with additional testing the platform can achieve if it's compliant with all the security interface requirements. And finally, we have the SBMR, or the server-based manageability requirements. The SBMR outlines the requirements for an ARM-based server to connect the SoC with the BMC, providing the standard interfaces that are common on most of the enterprise and servers available in the industry, built around standards like IPMI and Redfish, compatible with the OCP hardware management requirements, including the hardware management profiles, but also outlining ARM special interfaces because of the unique design of ARM server SoCs that have a microcontroller built inside the SoC and with a dedicated sideband connection with the BMC. Now, these standards are not developed by ARM in vacuum or just dictated upon the industry. This is an ecosystem with many partners and players, Ampere being one of the lead server SoC vendors that we work with, but we have also many other companies that we work with, including silicon partners, operating system vendors, independent firmware providers or BIOS vendors, PCI card vendors, etc. So this ecosystem working together in what we call the System Architecture Advisory Committee, you can think of it like an industry consortium that's sponsored by ARM for the ARM ecosystem. They work together on these specifications, they reach consensus, and that's how the rules get into the requirements. And those requirements, as you can see, they have a far reach that have implications on the platform firmware, but also the operating system. Sometimes the way the firmware is going to shape an interface for something new, let's say that will go into ACPI, is going to dictate how the OS kernels are going to implement that feature. In addition, this group of companies working in this consortium are not working isolated from the rest of the industry. We collaborate with the industry forums, including OCP. There are proposals sometimes that originate in the system architecture AC that then find their way into industry standards, UEFI, DMTF, PCI SIG, TCG, or OCP, and vice versa. When there are industry specification proposals or new revisions of any specification, they get also consumed by the system arch AC to find the rules around using that new interface within the ARM ecosystem. Compliance testing. ARM provides this architecture compliance suite, open source, freely available, that covers the different specs I talked about. So it's a modular suite that leverages both UEFI and Linux to test various interfaces, the firmware and the hardware interfaces, as well as the security interfaces I talked about. And some of it is original content that's written by ARM, that's open source. Some of it is reusing industry compliance testing tools like the UEFI self-certification test or the FWTS. This has been contributed by ARM last year at the OCP Summit as part of the test suite that can be used by OCP accepted servers that are based on ARM chips. The new test suite that we are announcing today, or we have just released recently, is the manageability compliance test suite. So this is a set of, again, an open source compliance testing a suite that is available on GitHub, published by ARM. It is based on the OpenBMC automation test, which uses the robot framework. However, it is not dependent on OpenBMC implementation. So you can run this manageability testing against any ARM-based server with a BMC to check the compliance testing of to check the compliance in the implementation of the BMC firmware, regardless if the BMC firmware is an OpenBMC based or some other BMC solution. It's testing interfaces, not implementation. And in fact, a lot of it could be applied to non-ARM servers as well, even though the rules are derived from the ARM SBMR specification. There is good coverage for redfish testing, as well as IPMI testing for those who still need it or use it, both in-band and out-of-band. For example, some of the testing included in this automated suite is compliance testing against the OCP hardware management profiles, so both the basic and the server profiles. This is just got released as an open source program on the ARM GitHub, but we are in the process of applying it as a contribution to the OCP GitHub as well. And we have been working, we have been working with the ecosystem on prototyping and testing this, including firmware vendors or firmware providers like AMI and Inside, including BMC vendors like ASpeed and Novoton, and silicon providers like Ampere and NVIDIA, and OEMs like HPE and Supermicro. And since we are talking about manageability and BMC, we have OpenBMC is an important project also for ARM as an open source BMC solution. Remember that our requirements or our standards do not require an open source solution, but it can be either open source or commercial solution for a proprietary or from an independent firmware vendor. But we want to make sure that there is enough in OpenBMC to support ARM server partners that would like to use that approach. ARM does have some proof of concept applications and drivers and porting that is published on our GitLab. One of note is a library to parse RAS error logs in CPER format, which is something that would be of interest to the hardware fault management groups, for instance, at OCP. This ecosystem is growing. As of today, we have more than 40 certified servers from many different silicon providers and OEMs across the ecosystem. And I'll hand it from here to Peter to cover the Ampere portion of the slides.
Thanks, Samir. As Samir mentioned, it's extremely important for standardization in the ARM server community for acceptance in the industry, right? So Ampere has been extremely committed committed to providing open source firmware for our reference platforms, as well as making those reference platforms, in some cases, available in the OCP community. Our first reference platform that was available in the OCP community was the Mt. Jade. The Mt. Jade was the first ARM server platform that was SystemReady certified. And the first SystemReady SR certified platform, the first ARM, as I said, the first ARM server that is OCP accepted. It's also OCP OSF compliant, so that means we can install Tiano Core EDK2, Linux boot, OpenBMC on the platform, and utilize it in a way that is similar to any other server platform that you would find, right? For more information on some of that, you can check out our GitHub repository located under our org, Ampere Computing, and also another organization, the other URL, github.com/Ampere Computing OpenBMC for our OpenBMC specific contributions. Additionally, there's support for AMI firmware, Aptio Megarack, and Aptio Megarack Open Edition. So now, recently we've started working on our next generation processor, the Ampere 1, and as part of that, we've been working to add SystemReady, or actually the Ampere Mt platform is now ARM SystemReady certified. That's the industry's first ARM SystemReady SR certified platform at the SVSA level 5. It's also certified with ARM SystemReady Security Interface Extensions SIE system. And then actually OCP Mt Ampere CPU hardware specification can be found at the at the following link on the Open Compute website. And it's OCP OSF compliant as well. So once again, that's TNO Core EDK2 and OpenBMC, and we can find more information on our GitHub. So as we mentioned, here's a snapshot of Ampere in the ARM SystemReady ecosystem. As you can see, there's lots of platforms that are already available, already certified, and ready to be consumed, in your data center today. Specifically, calling out some from like HP that we know supports OpenBMC, one of the first enterprise platforms available with OpenBMC directly shipped from the hardware vendor itself. So yeah, it's great to see the adoption of OSF in making its way into the mainstream, specifically, broadening the reach outside of maybe just the realm of hyperscalers. So, Ampere and ARM SystemReady community collaborations, some of the stuff that we've collaborated on was to eliminate barriers, to mass deployment, right? We want to directly enable OEMs, ODMs with, reference implementations of firmware, of the OSF firmware as well. As we said, specifically, TNO Core EDK2, Linux Boot, OpenBMC. We provide reference implementations that can be taken and used to help, our ODMs and ODXs, build an OSF strategy on top of the Ampere platforms that they are going to be building. So also there's AMI Open Edition compliant firmware that can be found on the OCP GitHub, and collaborations with trustedfirmware.org to enable trusted services as well. So as I mentioned, Ampere is committed to TNO Core EDK2 contribution and maintaining reference architecture, reference implementations for our OCP platforms. For more information, people can go to our Ampere GitHub, and specifically the GitHub URL located on this page. And we're currently, in the works. Work is in progress to bring EDK2 to the Ampere 1 family. Again, with Ampere and Linux Boot, we've done the work to enable Linux Boot for our reference platform. As I said, we started with Mount Jade. Linux Boot is a modern firmware for servers. We saw the previous discussions on it. And as I said, Linux Boot supports both Ampere Ultra and Ultra Max on Mount Jade. Our Ampere EDK2 GitHub has a build option enabling Linux Boot, and it'll replaces the BDS shell with Linux Boot and UEFI. So as I said, we also maintain a reference implementation of OpenBMC for our platforms. We continuously push changes upstream to our public repos and continue to work to enable OpenBMC for the platforms that are coming down the pipe for the future. So for Mount Jade, that basically consists of a lot of bug fixes, base meta, Ampere, and SFI bridge upstreamed. There's additional code and patches that go on a continuous basis that we've been putting in over time. And then now for Mt. Mitchell, there's initial support is available also in our Ampere OpenBMC GitHub, and Ampere telemetry support is there via MCTP and PLDM. So, for those interested, here's some of the work, and I'm not going to go into all the detail, but some of the work that we've done, on our OpenBMC roadmap, both this year and things that we're looking to do into next year. And then additionally, we provide debug tools to allow for, debugging of the platforms. So we provide, we've worked on Open OCD in the upstream community, and we provide patches continuously to maintain it for our platforms and the ongoing work that we do. And additionally, this is some of the work that was done this cycle in terms of OCD, OpenOCD, to enable it for the current work that's going on for both Mount Jade and Mount Mitchell going forward. So with that being said, here's a quick slide for anybody interested in more information. Please check out the Ampere developer community. And then, for a call to action, please visit the ARM booth and the Ampere booth. Check out our additional sessions here at the OCP Global Summit. For more information on the ARM SystemReady and developer program, you can find the links to both the ARM OCP Experience Center, links to join the SystemReady program, ARM Developer Hub, and ARM Developer Program. And additionally, for our Ampere Developer Program, there's a link to join. We have a developer community at community.amperecomputing.com, and you can sign up for our developer newsletter at amperecomputing.com/newsletter. Thank you very much, and let's open the floor for questions.
Do you have time for any questions? All right.
Any questions? Going once? All right. Thank you, everybody.